Bam Bam Resources has just completed drilling almost 15,000 feet in 14 RC and 2 core holes at the Majuba Hill Porphyry Copper Project. The 2 core holes were drilled in the copper-gold intrusive area and intersected diorite intrusive with widespread classic porphyry alteration and veining. The diorite, with copper mineralization, was previously unknown. We believe this diorite underlies most, if not all, of the well-known subvolcanic intrusive rhyolite assemblage at Majuba. The initial core logging indicates that the diorite is coeval with the upper subvolcanic rhyolite intrusive. Both core holes bottomed in the diorite at 1,017 feet and 1,802 feet. This drilling now gives us a total vertical extent of over 3,238 feet for the porphyry copper system at Majuba Hill. With this presentation, we want to provide a general overview of the scale of the copper, silver, gold system at Majuba and the magnitude of the intrusive setting for the emerging district. But it is the Christmas season, and we did just finish drilling, and all our 2021 assays are pending. So this will be the Christmas light version. Thanks, and lots of credit for the progress of Majuba Hill goes to a bunch of people. During the 15 years we've held and been associated with Majuba, there are more geologists, companies, and contractors who made contributions than I have to talk about in this presentation. However, we do want to thank Bam Bam and the management and the board for providing the support and backing to get Majuba into a modern porphyry copper exploration setting. Specifically, Dave Greenway, the president and CEO of Bam Bam, has been instrumental in his support and faith that Majuba always produces. We also want to acknowledge technical contributions and observations by the Center for Research and Economic Geology program at the University of Nevada, Reno, where Alex Holmwood is working on his master's thesis, and his crew, Matthew Harlow, his major professor, Phil Ruprecht, one of his advisors, and of course John Muntean, Dr. John Muntean, who's the director of the program. But also like to acknowledge Larry Segerstrom and Mike Russell, who are both on the Bam Bam Advisory Board. Of course, we offer the prophetic, forward-looking statement. Majuba Hill is a porphyry copper project in Pershing County, Nevada, that is 56 miles southwest of Winnemucca and 156 miles northeast of Reno, Nevada. Copper, tin, and silver mining started at Majuba in the early 1900s with production into the 1950s. It's likely that most of the recorded production of 2.8 million pounds of copper, 184,000 ounces of silver, almost 1 million pounds of lead, zinc, and 21,000 pounds of tin came from the underground workings at the Middle Adit and the Last Chance underground mine on the property. The 5,800 ounces of gold, recorded gold, probably came from the surrounding placers. As you can see from the regional geology on this slide, there are several larger intrusives in the region west of Interstate 80 that all intrude the Triassic age metasediments of the old Langsyne Formation. For scale, you can see the metric bar on the bottom of this simplified project geology image. These squares are whole sections. They represent square miles. Bam Bam currently controls 15.1 square miles, almost 10,000 acres, of surface and mineral rights. This includes 3 patented lode mining claims and 4 square miles of private surface and minerals. As you saw in the title slide, Majuba Hill is a prominent edifice. It is comprised of outcropping, subvolcanic, rhyolite intrusive rocks that are shown as this salmon-colored area, and we believe this is all underlain by the coeval diorite intrusive. It forms a circular pattern, as you can see from this topo map here underneath. The 2 core holes I mentioned in the beginning were drilled over here in the copper-gold intrusive area. Historically, this had been mapped as KTI granodiorite, Cretaceous Tertiary Intrusive Granodiorite. We now believe, based on this drilling, this is mostly diorite, and later in the presentation we're going to look at the project-wide geophysical data that shows why the diorite forms the deeper intrusive beneath the outcropping subvolcanic rhyolite, and very likely most of the rest of the property. The rhyolite and the diorite are both intruded into the Triassic Age metasedimentary rocks of the Old Lang Syne Formation, which is shown here in green. The Old Lang Syne Formation has primarily a northeast trending bedding foliation to it that dips steeply to the west at about 75 to 85 degrees. The subvolcanic rhyolite has widespread oxide and hypogene sulfide copper mineralization and porphyry style alteration. The deeper diorite also has widespread hypogene sulfide copper mineralization and porphyry style alteration. Compilation and interpretation of all the drilling, geology, alteration, geochemistry, and geophysical data over the last 2 years has led us to outline 4 intrusive centers: the Majuba Intrusive Center, the DeSoto Intrusive Center, the Copper-Gold Intrusive, and what we think may be the granddaddy of them all, the 789 Deep Intrusive Center. During the past 10 years, we have drilled, mapped, and documented classic porphyry alteration zoning in the surface mapping. Outlined here is the phyllic zone, which extends downwards and outwards to the propylitic alteration area. There are also zones of potassic alteration that outcrop on the surface within the rhyolite intrusive, mostly occurring as secondary biotite and potassic flooding. Compilation and interpretation of all this have led us to believe that Majuba Hill is a copper porphyry system with billion-ton potential. The next couple of slides that we're going to look at are along this cross-section line, looking towards the northeast. The rhyolite assemblage rocks were historically interpreted as a fan-shaped subvolcanic hypabyssal intrusive complex that spread outwards as it was intruded into the northeast trending foliation and bedding of the Triassic Old Lang Syne metasediments. But several years ago, we started to believe that the geologic mapping and geophysics showed a large intrusive complex that's expanded with depth. This concept was strongly supported in 2020 when we drilled deep core holes MHB8 and MHB9 that extended the limits of the rhyolite intrusive complex. And now, with the diorite in the 2021 core holes, the geophysics, soil and rock geochemistry, and the surface geology is much easier to describe and explain with a multi-stage telescoped intrusive event that is comprised of the coeval diorite and the subvolcanic hypabyssal rhyolite intrusive, with the diorite occurring under the Majuba Hill mine area, as well as peripherally all around Majuba Hill. In MHB 20 and 22, diorite dikes were intersected as shallow as 197 feet, with the main mass of the diorite extending from 654 feet to 1,802 feet downhole to the ends of the holes. There are 5 rhyolite intrusive assemblages that were mapped and described by McKinsey and Bookstrom in Nevada Bureau of Mines and Geology Bulletin 86. The detailed project geology map was originally based on the Bulletin 86 mapping. During the early days, for us sorting out the geology at Majuba, this map led us to use some geologic jargon, dog's breakfast. In the 5 intrusive assemblages, McKinsey and Bookstrom documented 34 different mappable units comprised of 20 distinct lithologies and 14 different breccia types. Each lithology was defined by phenocryst composition, size, degree of euhedrality for the phenos, along with variations in the ground mass composition and its appearance. But, except for the latite assemblage, all of them were rhyolites. So from youngest to oldest, we had the latite assemblage, and that extended to the deepest, which was the early rhyolite assemblage here. The 5 assemblages form both monolithologic masses and dikes. Each assemblage has brecciated varieties that appear to be lithologically consistent with the assemblage, but can vary in texture, matrix to breccia ratios, and whether they are matrix or breccia supported. Historic potassium argon dates from outcropping rhyolite porphyry, the latite assemblage, and veins gave Oligocene ages of 24.1 to 25.7 million years old. But we have new dating in progress, and we are certain that this is going to change. On this slide, the copper and silver oxidation, leaching, and enrichment are outlined in this red hatched area. Obviously, they're economically important because they outcrop on the surface and extend as deep as 1,490 feet in the rhyolite assemblages. The hypogene protor is outlined by the purple hatched area below. Previous core programs intersected sulfide ore primarily as chalcopyrite in holes that were drilled below the leached enrichment zones of the rhyolite. Since 2015, a staged exploration program has been used to sort out and evaluate Majuba geology and mineralization. It was guided by combining historic work with ongoing core and RC drilling, geologic mapping, IP and magnetic geophysics, and rock and soil geochemistry. This identified targets in the 4 intrusive centers that I mentioned earlier, as well as 3 additional target areas that have emerged with our most recent fieldwork this summer. But most of the drilling at Majuba has been focused in the Majuba Intrusive Center. Since 1941, there have been 8 drill campaigns that drilled over 72,000 feet in 100 holes at Majuba Hill, 7 by exploration companies and 1 by the U.S. Bureau of Mines. Prior to 1979, 25,380 feet were drilled in 29 holes. Freeport Sulphur Company in 1942, the U.S. Bureau of Mines in 1948, and then the early Mine Finders Group, headed by Stu Wallace, drilled about 22,000 feet of core in the early 1970s. Since 1979, but prior to Bam Bam, over 23,000 feet, almost 24,000 feet in 45 core holes and in 45 core and RC holes was completed at Majuba. Minterra in 2007 and 2008, Max in 2011 to 2014, and Galileo in 2017. Bam Bam has completed 23,606 feet in 7 core and 19 RC holes. So next we're going to look at a photo right through this area to look at the magnitude of the Majuba Intrusive Center, and then there'll be a corresponding cross-section that's oriented the same way where we can look at some of the data. On this slide, I want to show the recent drilling, but first I want to point out some key features at Majuba. First is the scale. This is a 2,000-foot scale bar across the bottom here that is for both horizontal and for vertical, just to give you some idea of the scale of just the Majuba Intrusive Center. Also, I want to point out the middle adit area right here. When I mentioned the historic production, most of the production of metal at Majuba just came from this underground access right here. This was driven in the early 1900s and is the site for most of the historic copper production. The lower adit, which was also driven, lower adit here, also driven in the early 1900s horizontally directly into the mountain underneath the middle adit, never had any production. These are the mineralization envelopes outlined in red here, the known copper oxide and enrichment zone that I talked about earlier. Green is the known copper sulfide with enrichment, showing here. And the purple outlines the sulfide hypogene copper protor in this area, which would extend at depth out of view here. Most of the drilling at Majuba has taken place within the view of this image. Shown here in the red triangles are the Bam Bam holes drilled in 2020, and in black there's 12 of the 16 Bam Bam holes drilled in 2021. In 2014, historic core hole MMX24 was drilled, and it really clarified this sulfide and oxide copper enrichment potential at Majuba Hill. The hole was drilled from the back of this ridge out towards us, towards our eyeballs. It intersected 370 feet at 0.45% copper and 9.9 grams per ton silver from 730 to 1100 feet. Overall, the entire hole intersected 1,200 feet at 0.17% copper and 8 grams per ton silver. Drilling by Bam Bam in 2020 verified the copper enrichment concept with core hole MHB2 here when it intersected 146 feet at 1.41% copper and 97.6 grams per ton silver from 0 to 146 feet. And so this next slide, and that was drilled away from us in this view. So this next slide that I want to is a cross section that is oriented just like the previous photo, right through here, looking north. Again, you can see the location of the middle adit in here and the lower adit down here. The most significant results for Bam Bam's 2020 drilling are also shown. I want to specifically point out MHB2, which was here, so that adit is here, and they only mined right in this zone right here. This whole collard up in this area, and in fact it's drilling away from us, but you can see the trace of this 146 feet of 1.41% copper. The lighter weight line, and I also want to point out MMX24 over here. You can see it's coming through the ridge. This area and through here is the 370 feet of 0.45%. So you can see where the mineralization was intersected in there. The lighter weight lines that are labeled pending are the same as the black triangles on the previous slide, and they show all the drill holes that we just completed to infill and expand the near surface oxide and enrichment zones for modeling and resource calculations. So we're working to connect here, where MHB2 outcropped at the surface, down into these deeper intercepts over here in 3, 4, 5, and 6, as well as MMX24. Next, what I want to do is show you a few photos of the copper oxide and enrichment zones from these drill programs. So first, we'll look at MHB1 and 2, the core holes, where we looked at the enrichment, the outcropping enrichment zones. Here you can see some 2 to 4% mineralization. You can see the blues in the azurite, and then the green in the malachite, as well as all of the iron oxide at 100 feet in MHB2. Here's a deeper interval. MHB1 was a vertical hole. Again, you can see about 2% material in through here. And then if we jump to MHB9, which was drilled from the portal of the middle adit and downward, you can see the native copper that this intersected. We believe that these oxide and enrichment zones represent the oxide enrichment zones. There are 2 oxide and enrichment zones. Both of them contain native copper at the bottom of them. native copper in this area, and then down at 986 feet in MHB9, you can see the native copper along the fracture patterns in through here. Here's a little bit deeper at 1044 in MHB9. You can see azurite and malachite just on copper, and then some copper on these fractures, and there's fine disseminated copper in through here. Just below this zone here, we now expect to go into the sulfide mineralization. With some of our infill drilling, this is a drill hole MHB14. There's nothing that'll make a driller happier than to see all of that green just pouring out of the splitter when you're drilling this with reverse circulation methods. So now we'll start moving outward to outline the magnitude of the mineralizing system at Majuba. We're first going to look at some of the deeper core holes, MHB8, MHB9, and then MHB20 and 22. Core hole MHB8 stepped out over 1,700 feet southward from the Oxide enrichment zone to test a deep IP chargeability high. This 1,635-foot long hole intersected over 1,200 feet of chalcopyrite in veins, stockworks, and disseminated with tourmaline below the zone of oxidation and enrichment. The broader interval of copper and silver in the sulfide chalcopyrite zone below the enrichment returned 470 feet at 0.1% copper and 4 grams per ton silver from 830 to 1,300 feet. Within that interval, in the sulfide chalcopyrite zone below the enrichment, there is 65 feet that went 0.35% copper and 13 grams per ton silver from 865 to 930 feet. MHB 9, as I said before, was drilled from the middle adit, and it drilled northwestward, and after going through about 120 feet of the vein and disseminated native copper we saw in the previous slide, in the lower enrichment zone, from 880 to 1,000 feet, it stayed in the rhyolite intrusive to the end of the hole at 1,812 feet, with extensive porphyry copper alteration zonation and veining with some chalcopyrite, molybdenite, and pyrite. So here we'll look at a few photos of the sulfides in MHB 8 and 9. Here you can see veining cutting some of the finer grained intrusive, and you can see chalcopyrite dominated, chalcopyrite much greater than the pyrite in this veining coming through here. This is at 1,459 feet. If we jump back up the hole a little bit, here you can see some veining where the pyrite is greater than the chalcopyrite. So there was chalcopyrite in through here, but it's more pyritic. You can also see the cross-cutting nature of these pyrite chalcopyrite veins, as well as there's a through-going porphyry style silica veining that you can see as these gray lines, and these are silica veins with cores of pyrite, and they are cross-cutting and multi-stage. Then if we jump down to the bottom of the hole in MHB8 as well, we saw this magmatic breccia in 2020, and these fragments are cross-cut by this same stockwork pyrite, silica pyrite veining, and then some of these fragments are actually surrounded by pyrite as well. It's a matrix-supported breccia. The fragments are highly rounded, obviously transported from a great distance, and this is a magmatic breccia. We also intersected granodiorite in the bottom of this hole. We now know with MHB 20 and 22 that we were just barely on the edge of the diorite body below and recognized the significance of that. If we jump out to 9, which drilled towards the northwest, here you can see a fluorite knot, and it's got chalcopyrite within it. This fragment had little pieces of molybdenite around the edges of it, and then you can see the nature of the rhyolite intrusive. And then this is the deepest part of the hole in through here, and again you can see this quartz pyrite stockworking that was chopping up all of the diorite out towards the end of the hole. There was also disseminated pyrite in this core. In the core holes just completed, there are numerous cross-cutting veins and stockworks of quartz throughout the holes, throughout the length of the diorite in the holes. Veins and stockworks of quartz, chlorite, quartz and feldspar pegmatitic type veins, and secondary potassic feldspar veins, all pointing to multiple magmatic hydrothermal alteration events in the diorite. All the vein types have variable amounts of chalcopyrite, pyrite, bornite, pyrrhotite, and arsenopyrite, along with minor amounts of molybdenite. Phyllic, propylitic, and potassic alteration is prominent in the diorite throughout the core. The potassic alteration in the diorite seems to occur primarily as secondary biotite, but we have often we see these pink secondary feldspar veins cross-cutting it. So just a quick look at some of this core. This is at 741 feet. You can see the equigranular nature of this diorite in here, but you can see these fragments in here. Tourmaline is a prominent piece of the upper rhyolite. It's a prominent late component. It's a prominent component of the system in the rhyolite, and now we are also seeing it in the diorite. This is giving us some indication of the coeval nature of the relationship between the diorite and the hypabyssal subvolcanic intrusive rhyolite. At 763 feet here, you can see one of these pegmatitic quartz feldspar veins. This has a molly selvage around the edge of it. I thought of these more as gash veins because they had big broad areas and then they thinned out. Also in let's see, those are the two for MHB20. So if we look at MHB22, the deeper hole here at 981 feet in the diorite again, you can see multiple cross-cutting quartz veins. This is was a white magmatic hydrothermal quartz. You can see cross-cutting relationships in through here, massive amounts of pyrite, and as well as vein selvages, another event. And then you can see this stockwork nature in through here. Most of this is chlorite veining with sulfides. There's a through-going ubiquitous chlorite vein event. This is probably the most spectacular from a metals viewpoint, from a visual metals viewpoint intercept that we saw. We had about 20 feet in here at 1381 in MHB22, and it was chalcopyrite dominated. Mostly chalcopyrite in through here. You can see some of the galena that also occurred in this hole, and then right around in through here, some of this red was sphalerite. This is in that same magmatic hydrothermal quartz in through here. You can see massive chunks of pyrite. Here the pyrite is greater than the chalcopyrite. And then if we jump a little bit deeper down the hole, this was really an interesting breccia just because of the variety, the multi-stage nature of this breccia. It is bound by two planar faults, but you have these angular fragments that are primarily sulfide and diorite, but they're pervasively they're flooded with pyrite. It's a matrix supported breccia, but the matrix is a mix of the granodiorite as well as pyrite. It's probably about 15% pyrite in the matrix, and then there's a late pyrite event. You can see it cross-cutting some of these frags that actually goes off through the matrix, but it's still bound by these features here. As I said earlier, since 2015, we've been using a staged exploration approach with project-scale exploration techniques to sort out and evaluate Majuba geology and mineralization. These techniques now allow us to visualize the scale of the porphyry mineralization setting at Majuba. For the remainder of this presentation, I just want to highlight some of these results. This is the copper and the gold in soils, and this is what we have gathered to date. There's 2,362 soils total surrounding the main mass, the main edifice of the Majuba Hill intrusive complex. Samples were collected on 200-foot spacing in 3 campaigns during 2011, 2020, and 2021. Significant zones of copper, silver, and gold were identified at the De Soto intrusive center and the copper-gold intrusive center. The De Soto anomalous copper zone is over a mile long and more than a half a mile wide at its widest point, and is outlined using 100 ppm copper in soils threshold. This area was explored early in our tenure by previous lessors, and in light of our better understanding of Majuba Hill, we believe this zone will become more significant. We're not going to discuss the lithogeochemistry from all the soils data that we've got, but part of our identification and separation of these intrusive centers is based on the lithogeochemistry. Each of these appears to have a different lithogeochemical signature. So we're excited by that because it's showing the multiple intrusive nature of the system itself. Because we think this zone is going to become more significant, we did drill 2 holes here in the 2021 program. We drilled a deep hole up here targeting the intrusive, and then we drilled shallower in through here looking for oxide enrichment in the DeSoto area. The new copper gold target zone is over 5,250 feet, almost a mile across. And prior to core holes MHB 20 and 22, this area had never been drilled. There were no drill holes in this area. The ferrocrete target here is a new target zone emerging from the 2021 soils campaign. Previous geologic mapping had identified ferrocrete zones with iron oxide cemented colluvial gravels in several areas along the top of the ridge, and then prospects down in here with and in the 2021 soils outlined a region confined by topography with anomalous copper, zinc, gold, silver, and iron, all anomalous both in the soils and in the surrounding rock chips. Integration of the geology, drilling, historical mining, and surface geochemistry with the drone magnetic and IP geophysical surveys presents extremely compelling evidence for Majuba to have billion-ton economic potential. Bam Bam and previous lessors completed 7 geophysical programs since 2007. In 2007, the original 3 IP resistivity lines with 300-meter dipole spacing, deep-looking lines, covered the main topographic edifice and historic mine area at Majuba. Infill around these 3 lines was done in 2017, 2018, and then in 2021 we did a 50 line kilometer survey that extended the IP resistivity coverage out to the northeast. Shown on this map is the reduced to pole data for the property ride drone magnetic survey that we also completed in 2021 that covered the complete property area. The drone survey was merged with the original ground magnetic survey from 2018, which was also done over the main edifice. And as you can see, these results really are remarkable. They showed that the tertiary subvolcanic rhyolite intrusive complex formed a prominent or a distinctive magnetic high. That's at least 2.5 times larger than what the surface mapping indicated for the extent of the rhyolite edifice. This much larger extent, shown by the positive magnetic response, matched the results we got with the 2020 drilling in drill holes MHB 8 and MHB 9. I want to point out a few features on this map. You need to keep in mind that total, the magnetics represent a 100 nanotesla range in the mag data. Very subtle. These are rhyolites. There are primarily, mostly what we see are rocks made of silica. So this positive magnetic high that matches our rhyolite intrusive is really interesting. Also need to point out probably the most important feature that's emerging from this data is the remnant magnetism. It's reversed magnetism because of the changes in the Earth's poles. So in the course of this intrusive event, we have this remnant magnetism, and here you can see this red line. This is a remnantly magnetized dike that when we went back out, looked at the mapping, and started infill mapping, we found a diorite dike that extends northward for 3 to 4 miles and crosscuts all of the rhyolite in this area. Also, these purple areas showed the remnant magnetization. Our original interpretation by Jim Wright, our geophysicist, suggested that it was the granodiorite that was given this signature, but we also had these purple zones out in through here and scattered all around the periphery of where the subvolcanic, the edifice, if you will, the upper zones, came closer to the surface. And this is the copper gold intrusive in through here. So we now know, based on the drill holes that are right in through here, that this really represents the diorite. This is a map looking at the IP chargeability results. This is just one of the products that we use. This is the depth slice for the 200 to 400 meter elevation. The IP resistivity program has proven remarkably successful in defining high chargeability and resistivity anomalies that correlate to the porphyry copper related phyllic alteration and sulfide zones that contain chalcopyrite, pyrrhotite, pyrite, and arsenopyrite. Specifically, we can point to this large IP high here. Now, this is the depth sliced version of it, but it was a very large high out in through here. And the very direct correlation between the high chalcopyrite, pyrrhotite, pyrite, and arsenopyrite in core hole MHB8, which was drilled right here to test this high, is a good indication of the importance of the IP geophysics for identifying drill targets and outlining the potential scale for mineralization at Majuba Hill. So in this depth slice, we've got these highs that are showing in through here, in this particular depth slice zone, out in here. So we recognize that the extreme utility of the IP geophysics. The IP resistivity results, this again is looking at a depth slice. This is looking at a deep slice, as deeply as we've looked with this data. This is the 400 to 600 meter depth slice. These results identified this extremely prominent resistivity response on lines 7, 8, and 9. Hence our name, the 789 intrusive, the 789 intrusive center. It's almost a mile across in its longest dimension, and then the eastern side of the 789 zone is coincident with the north trending remnant magnetized dike that comes right down through here. This survey was completed and interpreted prior to our 2021 deep core program, and at the time, with the interpretation, Jim Wright commented, our geophysicist, the resistivity annulus suggests some form of intrusive with surrounding resistivity alteration rim. Deep chargeability anomalies coincident with the rim indicate an increased sulfide association relative to the center. He concluded that associated with this feature are both shallow and deep resistivity chargeability anomalies consistent with a variant of the classic Gilbert and Lowell porphyry model. So when you have other people commenting about your property like this, I think I'll just leave you with this obviously borrowed image from Dick Silito's 2010 Economic Geology article. For the past number of years, we've been pursuing something that we expected to be economically significant at Majuba. We were working in this black circle area, all in the subvolcanic rhyolite intrusive portion of these models. We had all of the alteration that went in these zones, and we were very excited. We thought we were chasing large tonnage potential then. Now, with the discovery of the previously unknown diorite intrusive, which would correlate with the core of this model concept, we have a much fuller picture for what we were pursuing, and we think that that is much better outlined by this red zone. Thank you very much.